Hi ladies and gentlemen, I hope everyone is doing well today. Today we're taking a look at moles and reactions. Right up top we're starting with mole ratios and equations. This paragraph, this section is really important. Please make sure you understand it. If you have any questions, make sure you circle them, write down your question and bring it to class. Make sure you ask me. So in the first paragraph, the most important sentence is the last sentence. It's bolded for you. I also highlighted it. It tells us that the number of moles of each substance in a chemical equation is equal to the coefficients. So it talks about several examples in the paragraph. However, I wanted to compare propane to water because that is the first example. So we can look at the coefficients if we wanted to compare moles. So it would tell us 1 mole of propane. Remember, whenever there's no coefficient, we assume it's 1. If you want to write it, you're more than welcome to. So it tells us 1 mole of propane to 4 moles of water. Remember, if you were to write this as a fraction, the numerator is on the left and denominator is on the right would be 1 divided by 4. So for questions 1 through 5, you're going to be using this balanced equation up here to help you. Make sure you round each answer to 2 decimal places. So the first question is asking you to convert from moles of propane to moles of water. I know you haven't done one like this before, but don't panic. It's still a mole conversion. So we're still going to start with a T, like we have been. So you would start with a T, put what you know on the top left, 1.45 moles of propane. That's what's given to us. You'll notice that I included moles of propane here. Because you are converting to moles of water, if you don't include what the molecule is, it will get very confusing. I won't be able to follow your work, so you have to include what the molecule is. So if we wanted our moles of propane to cancel, we would need our moles of propane in the bottom, and then what we're converting to would go on top. Next, we would plug in our values. These values are the coefficients from the balanced reaction up here. So when we're looking at moles of propane, we would look up propane, the coefficient is 1. Next, we would look up moles of water, the coefficient is 4, so we put a 4. You just multiply and solve 5.80. Remember, it says 2 decimal places, so this 0 is important. Part B is just a mole conversion, so I helped you set it up. Remember, we did a T, but we're converting in the top, the moles from the previous problem. If we want our moles of water to cancel, moles need to be in the denominator and molecules on top. Your conversion is right here. 1 mole equals 6.02 times 10 to the 23rd molecules or atoms. Now all you have to do is plug the value in and solve. Question 2. Question 2 is just like 1A. We're doing a mole to a mole conversion. So we're going to have to use the balanced chemical equation. So we start with a T. What we know goes in the top left. Remember to include, when you write moles, make sure you include the molecule because you're converting to another one. It would get confusing if you don't. So moles of carbon dioxide, if we want them to cancel, the moles of CO2 need to be in the bottom. Moles of water, moles of H2O would be on top. Now you guys just need to pull off the coefficients from the balanced equation and plug them in the right spot. Remember, those are the moles. That's why we can do that. Question 3. Question 3, why is the statement false? If 10 grams of propane burn, you need 50 grams of oxygen. So this question is a little tricky. It focuses on language, so I wanted to talk about this, make sure everyone understands it. If you have a question, please write it down, make sure you ask me in class. So if you were to look at the ratio 10 to 50, it's still true, 1 to 5, because if you were to look at the coefficients, you need 1 propane for every 5 oxygens. So the ratio is correct, but remember the ratio describes moles. This problem asked us about grams. If you are given grams, you would need to convert to moles and then you would be able to compare with the ratios. Remember, the ratios only tell us moles. That will be important on question 5. So next, question 4. Question 4A and B is very similar. Question 4A is just like questions 1A and 2 when you did a mole conversion using the mole ratio. So base here steps off of 1A and 2. 4B is just like 1B, but instead of converting to molecules, you'll be converting to grams. Remember, when we're converting to grams, 1 mole equals the mass from the periodic table. So you'll just need to find the mass of carbon, oxygen, and then add together. Question 5. Question 5, so I wanted to take some time to talk about. So this is one of the questions where it gives us grams first. So if we're given grams, you just need to convert to moles. Once you convert to moles, we can then use the coefficients to compare them. It's important to remember that the coefficients only tell us moles, they don't tell us grams. That's why we need to convert first. So it gives us propane. So the first thing I did was find the mass of propane. So these are the values from the periodic table. Mass of carbon multiplied by 3 because you have 3 of them. Mass of hydrogen times 8 because you have 8 of them, 44.097. Next, we would do our conversion. So we would set up our T. You would have your 410 grams of propane on the left. You need to put your grams of propane on the bottom with moles on top. So remember, this is our conversion to moles first. That would give us 9.3 grams of moles of, sorry, not grams, 9.3 moles of propane. So then step B, step 2. Step 2 is now picking up where we left off. If we wanted to compare it to oxygen, now we would just need to convert to moles of oxygen. So this is where we would use the mole ratio. So we take our 9.3 moles of propane, and then we would convert to moles of oxygen. If we want our moles of propane to cancel, moles of propane go on the bottom, moles of oxygen go on top. Remember, these values are the coefficients from the balanced chemical equation on the front page. That would give us 46.50 moles of oxygen. So remember, I wrote O2 as well. You have to remember oxygen is diatomic. So remember, diatomic molecules, they don't like to be alone. They're so reactive that they bind with themselves before they're alone. So anything that's diatomic, we need to remember that it's O2. That's really important when we're finding the mass down on the bottom when we're converting to grams. So that's the last step. Now we convert moles to grams. So just remember, you need to take the mass of O2 because oxygen doesn't exist alone in the real world. So this mass right here is the mass of oxygen times 2. So the same thing, we just converted, mole conversion, moles to grams, moles of O2. We need our moles of O2 to cancel. They go on the bottom, grams go on top, mass from the periodic table. Then you solve. Remember, round to 2 decimal places. And then lastly, question 6. So question 6 is just like question 5, except it doesn't break it up to you in A, B, and C. You just need to do the 3 steps out. This question, so the 3 steps would be for this problem would be convert your grams of NH3 to moles. Remember, you're starting with 425 grams, so you could do a mole conversion first. Then you would need to compare with the mole ratio. So this one is asking us to do it for H2 and N2. So that's what you see here. I broke it up twice. So on this side, you're going to have to compare the mole ratio NH3 to H2. This one you're going to have to do NH3 to N2. Remember, your balanced equation is right here. So you use the coefficients to help you. And then lastly would be a mole conversion, which would be like in step C. Step 3, you're going to multiply the moles you found in step 2 by the mass on the periodic table. Remember, you have the mass of H2 and N2 because they are diatomic. If you have any questions, please circle them and bring them to class. I hope everyone has a good day.